said, my name is Tyler Wall, and I also wanted to thank everybody for being here today. It really does mean a lot to all of us students who have put so much time and effort into all these projects. So I want to thank you all for being here. And I am here to represent the Automated Aerobic Composter Capstone team. And real quick, I also want to give a quick thank you to our two advisors, Dr. Jay Noggle and Dr. Agundapi, for being very helpful and great advisors. So we started our capstone journey our junior year when we were chosen to be a part of the Biomimicry Global Design Challenge capstone. And it was introduced to us by an organization called the Biomimicry Institute, which had the simple prompt of climate change is an issue, solve it with biomimicry. And that was it. It was a very broad scope, and none of us really knew how to tackle it at first. So we said, okay, let's break this down a bit. And let's start with the biomimicry part. So we tried to figure out what that term meant, and we went to the website's webpage to see that they define it as it's a practice that learns from and mimics the strategies found in nature to help solve human design challenges and find hope along the way. Great. We had one part of the puzzle done. Now we had to figure out the whole climate change part, which is a very broad scope. So to help us understand what climate change was and the whole spectrum that it can cover, we looked into a whole bunch of different areas like the impact of different forms of pollution, the destruction and loss of ecosystems, even how natural disasters can contribute to climate change, until we all came to an agreement that one thing we knew was a major contributor to climate change was pollutant gases in the atmosphere. And when we researched more into these pollutant gases, the statistics behind methane actually very much stood out to us. Now, I know everyone talks about CO2 being a very dangerous pollutant gas and very abundant, but with methane, it can be 28 to 36 times more effective at trapping heat in the atmosphere and deteriorating the ozone layer at a faster rate over a 100-year time span. And that's just over 100 years. And after 100 years, the methane will turn into CO2 anyways. So in our view, methane was a very big deal, and we wanted to focus on that. But that still wasn't focused enough. So we decided to look further into methane, where it's produced and where it's concentrated. And we found that landfills, moreover, the organic waste that goes to those landfills, produces a large amount of methane and CO2 while undergoing anaerobic decomposition, which is the most basic form of decomposition. So, using this knowledge and this scope, we decided to develop an aerobic composter, with aerobic meaning that our composter would try to meet certain conditions for aeration, moisture, temperature, and humidity levels, a perfect mix of all of these criteria, so uh, uh, that way it could skip over the production of methane and just produce CO2, since we'd much rather have CO2 instead of methane. And to do this, we started using that biomimicry aspect. We started looking at all these different plant and animal species to kind of help give us inspiration for the subsystems that we wanted to include. And for example, we for one of them, the shape of our composter was inspired by a beehive or a honeycomb to maximize the amount of space we could maximize the amount of space we could use. Another system was tree roots helped us to inspire the aeration system, so that way the system was well aerated, among other systems that we bio-inspired. And then we submitted this design to the Biomimicry Institute at the end of our junior year. And during the summer of 2020, they got back to us saying that we were not awarded placement nor extra funding, but we did receive an award of merit, which we were very proud of. And regardless of the funding or any of that extra stuff, we still wanted our project to leave an impact. So we decided to just shift our stakeholders and our end goal. We now want our composter to serve more as an educational tool to guide young students K through 12 in learning various methods of composting and how to learn from biomimicry. And while trying to find a new stakeholder, our teammate Elizabeth Tafoya told us about her mother, Ms. Tafoya, who is an elementary school teacher up in Pennsylvania who's always trying to get her students more involved into science, especially through the locally well acclaimed STEAM Day. And so, using having them as stakeholders and having this new focus, we decided to repurpose all the material and all the knowledge from our original composter design and repurpose them into a new one. We wanted to iterate on our old design to help teach our students about many different lessons like different forms of composting, how to use a scientific method, how to take data, and a whole bunch of other tools that they could use later in the science. We began to come up with a completely new composter, one that used a scooter motor and augers to help mix up the compost in the composter to better aerate the system, circuit setup so that way they can measure the temperature, humidity, and moisture levels and take data on those, LED screens so that the composter could actually display the data so that if the kids wanted to take the data, they could. And we even started collecting the materials we would need to build up the structure of the composter, like an acrylic cylinder tube and sheet metal to make the base and the auger. And all of this we were trying to collect and combine together so that way we could have a schematic, so that way we could build it in the spring of 2020. And although we couldn't physically make the automated aerobic composter during this during the semester due to the situation the pandemic has created, we still wanted to help these students learn about composting and biomimicry, even if it's not in person. So we decided to make lesson plans that would have gone with the composter originally, lesson plans on composting and biomimicry and a broad range of other lessons. So that way, these students can learn all about the composter, even if it's not right in front of them at the time. We have also been creating CAD models, so that way, if anyone wanted to know how all the subsystems work together in the composter, they can look at the schematic and understand that. Or if they even wanted to build it at home as a little do-it-yourself project, they even can. Our team has learned many lessons from the many stages of building this composter, and we learned a lot about biomimicry, composting, the engineering design process, and being flexible engineers. And our hope from this experience is that students and even everyone viewing this, that you all can take away some of those experiences too, or learn something that we never even learned about our composter. That's our project. I want to thank you all again for your time and attention, and I will now accept any questions you may have.